confidence in him. We seek guidance in him to lead us to the straight path. And we pray to him to give us good health and guidance, peace and prosperity throughout. And we thank him for providing us an opportunity today to come together on the occasion of the MFIRD weekly event. And for the topic today, digital twin. I, Zakir Ahmed, working in HP. Almighty has made me a software engineer, working in HP with a total stint of around 18 years in the industry. Would like to present a few words on the digital twin topic today. So we welcome you all to this topic, digital twin. So before we start into the topic, let's see what we have in store for today. So let's start off with the basic concept of digital twin, understanding the overall big picture of what a digital twin is. We will see why it is used, the applications of it, and which are the industries which are adopting digital twin today. We will try to cover 4 to 5 use cases for this one from the different domains. Knowing all these things, how I can get started, what are the tools available today, and as a beginner or as a learner, open source stuff, which is the one that is available today, and how I can get started. So after this, we'll open up the floor for the question and answers. So till then, a humble request, if you can hold your questions, maybe it might get answered over the period of time. And at the end, we'll try to answer the questions. With this in mind, so what is a digital twin? Digital twin, we have 4 things inside. Number 1, it's a digital representation of a real physical device. Once you have this digital replica, then the real world data will have to be integrated to this. And once we have this real world data, it will start mimicking, it will start behaving as if it is a real physical device. So we do a lot of synchronization so that we get the data and our twin will always be up to date. So here there is a catch. So here either we can make it up to date or we can say, no, I want the data only till some certain X amount of time. So apart from that, so once you have this data from the digital replica, from the digital twin, what will you do with this data? Using this data, we will derive insights using the languages like computer vision, using the platforms like computer vision, machine learning algorithms, so that we can use this data and derive the required information. Number 1. Number 2, you can use this data and try to model around what exactly I mean. I'll just show an example at the end when we go through the examples. So we get some X amount of data, and using this X amount of data, you can create different permutations and combinations, and hence we'll be able to generate different amounts of data. At times, if this data is not sufficient, then we might even create the synthesizable data, and this data will be provided to the AI algorithms. And using this algorithms and the data, we will be able to derive different insights. And these insights are very powerful. So I can explain this with an example with the diagram going forward that will make things clear. But before that, we need to have certain things clear in our mind. These are 3 different words that are used today. One is the digital model, where we have a physical object, we have a digital object. But there is no data exchange between physical and digital world. So this kind of the model is called as the digital model. Then this got enhanced to something what is called as digital shadow, in which there is one-way data communication from the digital object to the physical, sorry, to the from this one-way communication, either from that to this or from this to that. Then this also did not solve today's problems. So then people went ahead with the implementation of digital twin, where the physical object can send the data to the digital object so that the digital twin is updated all the time. At the same time, using this data, using these things, the digital object can also send the feedback mechanism to the physical object always. That means to say, you can also control the physical object from the digital replica. This is a two-way communication, and this is exactly what is called as the digital twin. Though the technology, though the wordings, all these existed quite some time before. It all started with the NASA developing a digital twin for its own spaceship, what they call it as lunar model. So there, just imagine, for example, if at all we wanted to create a product, so we make the product, we test it, and then we launch it, right? So imagine NASA has to send the spaceship to the space. And how can it test? It cannot send the spaceship to the space and then test it, right? Whether the speed is okay or whether things are okay. So what does it do? So basically it created a twin of it, created this twin of it, modeled the data and tested it upfront before even the launch could have happened. So this concept came from that, and over a period of time, with the maturity of the technologies like IoT, AI, and all these things, this concept became prevalent in today's era. And that is why industries are investing a good amount of time, effort, and money towards digital twin. So with this background, let's understand this in detail. So what exactly happens is we have a physical entity. Let me use a pointer. We have a physical entity here. This is just a very simple example. So this physical entity has n number of sensors in it. So these sensors will sense the required amount of data and will be able to transfer this data. So this is the first level. And equivalently, we create a virtual model out of it. There are different ways of creating this virtual model. What I am interested might not interest you. What you are interested might not interest me. People of different backgrounds will be interested in different things. For example, if it is mechanical background, they will only be interested in the mechanical parts of it. People from the electronics background might be interested only in the electronics part of it. So different ways of creating this digital replica. So once this digital replica, and people might use different tools for creating this digital replica. People from mechanical, people from civil might always prefer to use CAD tools. So using CAD tools, they will be able to generate a digital model out of it. Once digital model is there, so in whatever form you create, ultimately it's a digital model. Once you have this digital model, then the data is taken from this and sent to this digital model through the sensors. And this is where IoT comes in picture. Initially, you have embedded systems where the sensors are connected. The sensors are taking the data, receiving the data from XYZ inputs, and are giving the output to whatever they are designed for. For example, if it is temperature sensor, so it's taking the temperature value and giving the value outside. So what will you do with this value? So you take that value and send it to the digital twin. So this digital twin now, basically digital replica, is now equipped with the real-time data that is coming from its own physical object. Once you have this object, then you have different steps to do. If I'm not interested in anything else, then I will just use this data and give it to the decision making or give it to the data analysis or give it to a data insights to generate the insights. Only doing this part is what we call it as monitoring. Maybe in the next slide, I'll explain the different applications. So we have this data here. So if you are just monitoring this data, then that's one application of digital twin. Going beyond that, you have this data. Now you can model this data. So you have X amount of data. So using this X amount of data, now you can think of sending this data in a different fashion, or making this data come in at different time intervals, making this data in different order. So what is the output expected? Is it going to crash? Is my code going to work? All those things can be done with this type of modeling here. So this from here, basically, we have different simulation models. So the data coming to this simulation model will be from this place. So once we have the simulation model, then this one is given to the process model, depending on what we are doing. So basically, it's given to the it's given to the ML AI algorithms as input. So basically, that's the data that is coming out of the simulation. So this data is now fed to the algorithms of AI ML, and this AI ML algorithms will now process this data and generate different insights. Let me give an example for you to understand. Maybe Tesla has their own digital twin, which we'll cover later. So the car is having its own digital twin. This digital, so as a simple example, so let's take a crash analysis. I want to see when my airbags have to be blown. And you remember the time taken, or the time at which the airbags have to be blown is in few microseconds. The moment the crash is sensed, then within few microseconds, the airbags have to be blown. So you don't have a big time there to think over what should I do? Should I blow this airbag or not? Those decisions cannot be delayed. It's time critical. So in that scenario, assume that there are three sensors. One sensor at the bonnet, which is indicating the pedestrian or the obstacles. Whenever the obstacle is closed, or it's closed, or it has hit the obstacle, then this sensor will send this information X. And the engine will send some information Y. And the infotainment or the other sensors might send some information, say Z. So you have got three informations. So you can have different conditions. I'm just giving you an example. So you can have different conditions. If X and Y and Z blow my airbags, if X or Y and Z blow my airbags, what happens if I'm not able to get Y at all? My sensor is gone. Does it mean to say my function will not work? My function will not work. So these kind of different simulations, will have to be modeled. This is what we call it as data modeling in the case of simulation. So once we have this done, then the AI algorithms will use this data and generate the insights, and this insights will be analyzed. Whether in this case, for example, so if this data is given, so should I blow my airbag? Should I not blow my airbag? Or should I wait for some other thing? So all these different scenarios are checked. And is my airbag blowing algorithm, or is my airbag blowing scenario all successful? So this is how one will evaluate this one. So we have different scenarios. One is only monitoring. One is it will generate, or it'll model the data, and it'll predict the output. What happens if this is this way? Then you'll do risk analysis. So is my code good enough? Is my model good enough? It's what risk is it? And then you'll start optimizing. Okay, this might not be the right way. I have to do this way. So then we'll use the optimization. So basically, this digital twin is used for 4 different scenarios. One is monitoring, one is prediction, one is risk analysis, and one is optimization. Monitoring might not exactly need the AI tools. It is just a data visualization of what you're getting from the physical object. Prediction might use some of the tools of AI to predict whether this is good enough, whether this is bad, whatever it is. And optimization, of course, will need the highest amount of AI tools. With this background, let's see the different types of digital twin. It can be as small as the smallest pump, one sensor, or one small component of a system. It can be a complete system, and it can be system of systems. So these are different types of digital twin, and we have different levels of digital twin as we talk about going forward. So here, as we saw, the different technologies are joining their hands together. Earlier, it was just if I know embedded systems, good enough. Then if I know only IoT, good enough. AI, ML, I'm an expert, good enough. Now, the ecosystem is important. How these technologies are crossing the roads. How these technologies are joining hands together. How these technologies are talking to each other to solve a problem. So in this world, we are talking of solving the digital twin problem, and hence we are using all these technologies put together. And that's why this is a hot topic today. And this, people say, is a stepping stone for the metaverse to happen. Let's take some examples how the industries are using this. In the field of automation, in the field of automotive. So Volvo cars have embraced this. Tesla has embraced this. Why they are using all these things? So they are used to simulate and test new design concepts before they are built, so that the production processes are optimized. And they can even predict how a vehicle will perform in different conditions. They are used typically in the 3D car design and development, so that they can use, or they can model, they can create the digital replica using their CAD tools, and then think of designing how it should really look like. Further, it's used in human-machine interfaces, HMIs, for in-vehicle infotainment and digital cockpits. Nowadays, it's also used because the move is towards the autonomous driving. It's also used in the case of autonomous driving simulation. You can believe Tesla is creating a digital twin for every car made. And this has used this technology, or this has embraced this technology so much that they themselves have their own digital twin technology. To understand more in detail, I'll play this video.
It's not a car. What you're looking at is a...
Hope my sound is visible. So hope my sound is audible. Hello?
Yes. I mean,
Yeah.
We can hear you.
digital twin. And what is that exactly? Let's find by going back in time. Here is a group of engineers and designers working on a new design. Back and forth, scale models, prototypes, testing, mishaps. It takes a lot of time and costs a lot of money too. All until digital twins hit the scene a few years ago, in which we are now investing to develop powerful tools and high-tech solutions. Ever since then, when designing a new model, we create its ever-evolving digital twin, a virtual model stored on the cloud that all authorized personnel can access. They can test, alter and interact with the model in the shared online space, the company's virtual replica. But the digital twin is much more. You have the virtual scale model, a 3D object with as much detail as the real thing. Thanks to high-powered algorithms, we can determine a car's handling, aerodynamics, and even test onboard safety equipment. No need to make a physical prototype for every stage, its digital twin is a perfect substitute. A vehicle is a minefield of calculations. You have to check that everything works as planned. That brings us to part 2 of our twin. Engine settings, ADAS, everything can be done with the twin. Seated behind a driving simulator, test drivers put cars through their digital paces on virtual roads. Safe, affordable and fast, an ideal addition to road tests. Part 3. Manufacturing. The digital twin is also a true-to-life virtual factory. Organizing production, sequencing operations, monitoring each part, everything is tested and confirmed via the digital twin for optimal production output. Last of all, vehicle monitoring throughout its life and even after its initial purchase. From design through to updates and retrofitting, everyone works together over the cloud. The real-world vehicle and its digital twin constantly learn from each other and feed into each other's design. And as with the dawn of every new era, we will look back on today in a few years' time and wonder, just how did we do it before we had digital twins?
Yeah, so as you saw, digital twin is getting adopted or has already been adopted in the field of automotive industry. Further, in the field of aerospace, in the field of architecture, so Boeing has created its own digital twin of one of its planes, and they claim that whatever data that we got was not enough, and we had to model it. We had to create 100,000 synthetic images to train the machine learning algorithms of the AR application. Further, in the interest of time, so in the case of architecture, Shop is a company. I can choose, I'll run the video, you'll understand it better. So these guys have used the digital twins to envision skyscrapers before they are even built. I'll just play this video for easy understanding.
I don't think I'm a techie person. I think I'm enamored with technology. We knew that the generation ahead of us could get much larger budgets because of their proven track records. And we knew that by heavily investing in technology, it would allow us to jump ahead and have opportunities to do projects that other people in our generation didn't. That's how I found out about Unity. As an architect, you're thinking about a world that is yet to be. When you build the model, it's the first time you build the building. The same place you can't get two sticks to go together and you're holding it with glue and trying to get it to stand, that's the same place the contractor has a problem in the field. So you begin to learn about the building just by going through the process of building the model. By being able to build it fully digitally, it eliminates so many of the problems that then happen after, because you find the problems when it's light and cheap and fast, not when it's heavy and glued and nailed and together and really expensive to take apart. So I can't think of anything more important, both from a design perspective, a construction perspective, but also from a carbon footprint perspective as the digital twin.
5 years ago, we relied on traditional renderings and sketches to work through design challenges. Having the right visualization tools is critical. Only when you're truly able to understand a space that doesn't even exist yet are you able to make an informed decision as an end user and commit to the significant personal investment.
We're developing something that we are calling the Shop Portal Immersive Suite. The premise behind the suite is to give our internal teams, our clients, stakeholders, consultants, a hub in which they are going to be able to, and are already able to, view all of the information for their project that they need. The first project that took advantage of the Shop Portal app is the Brooklyn Tower.
Most clients are not trained to look at traditional drawings, but they can see and feel things in 3D that they can interact with in ways that drawings never allow them to do it. And so being able to use the apps that we've developed with Unity to help people envision what it's going to be before it's there is invaluable.
When we pull in the Brooklyn Tower model into the Portal mobile application, we're able to look at renderings, we're able to look at live construction data. Building owners are able to take these tools and all of the information and data that we've created for them and be able to manage their buildings in a more efficient and economical way.
The biggest challenge in construction with cost saving is time and lost time. With real-time data, we can make decisions faster with every single partner on the project, whether that is with our communications team, our marketing team, our engineers, our facade consultants. Real-time data is power.
One of the things an architect has to instill in their clients is trust. And trust comes from being able to demonstrate to your clients or partners what worked and what didn't work. If we have the real data, we don't have to follow top-down prescriptive rules. We can have sort of responsive solutions for each individual circumstance. It's incredibly valuable to go to a client and say, here's what I feel, and here's what I think, and here's what I experience, and then here's the data to back it up. That's a pretty powerful argument.
So as we saw, the shop themselves have developed this digital twin, and the first project that they have deployed on is a 93-story in a skyscraper in New York City. Going forward, just not this. So every industry is trying to embrace this technology. The healthcare industry has just begun to benefit from digital twins. Though there are, it's in still nascent stages, still there are a good amount of remarkable breakthroughs. Scientists are using the 3D digital twins to mimic the cells in the patient's heart to determine if the surgery is required, not required, risky. All those things are also used to create the personalized medicines as in to create the prosthetics that are personalized, to create so in the field of regulations, so medical device development. So regulators are trying to explore the use of digital twins for modeling the personalized medical devices, like with assistive technology and other equipments. Disease modelings, as you can see here. So this is already used to study the diseases like Alzheimer's and multiple sclerosis, so that they can understand the disease better using this digital twin. Further, they are also using this for simulations of new treatments. Believe me, one of the highest time-consuming process for any drug to come out to the market from the innovation. So this typical time of close to 6.5 years. It's claimed by the US that for any drug to traverse the stage from the innovation to the market is close to 12 years. And now with these technologies, it has come drastically down to almost 1 to 1.5 years. And especially during the Corona time, you saw that it was much faster. So now this has become a trend now. So they are creating simulations of new treatments, and even the FDA has come out with different processes for this one. Further, digital twins of organs, a genome or a cell can be generated. Hence, research for particular cell, those things can also be done through digital twin. Hospital operations, as we saw in the last video of the designing part. So this is also coming in handy. So I'll just move faster because we have to cover more time in the demo part in the other part. So just one more scenario of the industries adopting digital twin. It is helping builders, planners, and operators across cities worldwide to better understand and optimize the space of the public use. So by using the advanced interactive models and live IoT data, the stakeholders who are creating the smart cities will be able to simulate traffic flow, mobility patterns, and even the effects of timing, effects of climate changes, and shifting landscapes so that they can plan where the airport should be, where the road should be, how the transportation should be, how many metros are required. All these things can be used with the help of digital twins. So with this one, let's move on. Basically, this is just to tell that how important this is and how people are already embracing this. In digital twins, we have multiple levels. So this is a very simple level, a virtual representation of an asset. And this one, we have the second level, which is an informational twin, which is used for at least one functional information purpose with using historical data. And this is actually where the things start. This is an operational twin with the IoT integration happening here. And this is the ultimate thing, which is called the connected twins. So this will connect to different modules or different systems. Basically, you can consider this as system of systems. And this is system. So this is a system of systems where everything is connected and you sitting in a PC can know whatever is happening on the real-time physical object. Well, so this is all about the theory that we had. So now let's move on to, okay, all this is fine, good, well, but how should I start doing this? So you have multiple tools to create the digital twin. So MATLAB is offering, Amazon AWS Digital Twin Maker is there, IBM Digital Twin Exchange. These are some of the tools though. Microsoft Azure Digital Twin Explorer. So all these four, or there are many, which we have shown here, they are all paid tools. Of course, they have invested good amount of time and money in this one, and hence they want to reap the benefits as well. And it provides different extra features as well. So for the open source, we have Eclipse Data. So Eclipse, as you all are familiar with, is an open source platform, is an open source framework. So they have a plugin called as Ditto. So this is for creating the digital twin. So we'll just go through this one and understand how to create a digital twin and how people are creating. I might not be able to show the one that we have created because of the company confidential information, but we can just get a feel of it. One second, I'm just sharing my other screen. Yeah. So this is in a pretty nascent stage that we have what I'm showing it to you here. This is a simple Ditto Explorer. So if we start off with this one, so this is the one that we have installed in our Linux machine. So this is a very simple UI Explorer. There could be much catchy things, but here what we have done, I'm just showing it to you. Yeah, so here for us to understand these things better. So this is a Ditto Explorer, and this one can be configured to use it on a local one, or can also be used to take it from the cloud. So this one has its own cloud. Where is the cloud? The cloud is sitting here. Ditto Eclipse Projects IO. So they have their own clouds here. They have their own cloud here, and things are getting fetched from this one. So you can configure it to be on cloud, or you can configure it for it to be on a local host as well. So now you need to understand these three things. What is the thing? A thing is basically a digital twin ID. A thing is a digital twin, which you need to create. Can be a very simple thing if it becomes, as we saw, 3 levels, right? It can be a very small thing, which is a system, which is a small unit of a system, and which it can be a system, a complete big thing, or it can be a system of systems. Like Tesla has created one thing ID. Basically, for every car, there is one thing ID. If at all we are interested in doing very small things, then we can start off with one sensor can also be a thing ID. Like these guys have created somebody. So this is on the cloud. Somebody has done this one bed. So this is a sensor. So what to understand the sensor? So this is a heart rate bed. This is a bed, and they have connected. This basically this could be for the hospital, and there is a sensor connected, and this is a heart rate. And this one will get updated as in how the physical object will get updated. Similarly, you can have a bigger things with multiple features. Before they're coming to features, so there are something called as policies. So like everyone cannot have access to every other thing. So you set up the policy. What is the policy I need to have? The policy will tell about the permissions that I can give access to, the readable, writable, modifiable permissions that one can have. For example, let me see if I can load this policy here. Here you see. So the read write is granted for this one. So this is a policy that one will set to his own digital twin. Who is having what policy? And then having that, we will talk about features. So here, this feature is for this particular thing ID. What are the different features that I can add? For example, if in this case, it is a unit of a system, just a sensor. Assume it's a system of systems, then you can have all different sensors coming here. The sensor of the bonnet, in fact, and the pedestrian sensor, or the engine sensors, or all these things, whatever you are interested in, can come all those things here. And for every feature, you can have the properties. So this can also be multiple properties. So basically, what you need is a thing ID, and for what you are defining your thing ID, it needs to have some features. And for whatever feature you are looking for, it needs to have properties. If you don't understand all these things, very simple. If it is just one sensor I'm looking at, for example, if it's just a temperature sensor, then it's just a sensor one and a sensor and a temperature value. Like in this case, it's just a heart rate value we have. So here, if you go on seeing other things, see, these guys have done 2 features, water tank, and these are different properties that somebody has done. Water amount, temperature, the smart mode, brewing temperature, temperature to hold, timeout seconds. So coffee brewer, how many coffees are brewed? So basically you can, so this what I'm showing here is from the cloud. So since somebody has given the permission, the policy that they have set as anybody can use, I'm able to see this. Had they said that I cannot give everybody to see my thing IDs, then they will not have given the permission, and that's why it might not be listed out here. So this way, you can create, you can meddle around, you can play around, you can do things free of cost with this Eclipse IDE. So this is just the monitoring part. Now coming to the simulation. Simulation, you can also use this Eclipse itself has provided some simulation tools. Apart from that, you can also use simulations like Simulink from MATLAB. So even we have not gone to that stage. So while we did a simple POC concept, so we also tried to do using this Ditto Explorer. And our use case was also for monitoring as of now, which we need to enhance going forward. So this is a kind of GUI or a kind of tool that one can start using it, Eclipse Ditto. If you just type in Google, you'll get to know Eclipse Ditto. You can download, you can install. This is on Linux, you can install on Windows as well. So you can start exploring things if you're interested in. Now, coming to the last part. So as any technology, every technology is also, has its own pros and cons. But before going to the pros and cons, so these are the 5 steps that one need to have for the complete digital twin to happen. So you need to design the virtual representation of the object. Basically, you're trying to simulate the behavior and characteristics of physical counterpart. You need to have the data integration, data coming out from different sensors of IoT, keeping the digital twin up to date. And all this information is stored in the cloud. It's up to you to store in the cloud or to have a local cloud by creating a local cloud, local information. Monitoring and analysis, monitor the data, what you have obtained, and use this data and feed it to the AI ML algorithms to analyze this data. And then using this data, you will show the insights to the end users. How to show the data to the end users? It can be as simple as a simple graph, or as complicated as the shop architects have used it to show the buildings, and to create a good experience to the users, they create the AR, VR immersive experience. Further, once they have this information, somebody can say, no, I don't want this to happen. The customer can say, can it be a better done like this? Or can it be moved to this one? Can this block be moved to this one? All that optimization, like as we saw in the case of Renault case study, that initially the blocks were placed as 1, 2, 3, 4. Then after finding through this digital twin, they found that it was in the different order made the difference for them. So this way, optimization and continuous improvements can also be given as a feedback to the same digital virtual twins. So the challenges, as I told about, so just because we have digital twin, we cannot start using it in all the fields that we have. It has its own set of challenges. What are the challenges? And this can be in the research area for the people who are here on the research. So connectivity is a big challenge in a sense, as we told, that this data has to be given to the virtual object. How do you give this? It can be, not every object is connected. For example, if I just have a simple temperature sensor, I cannot have the connectivity. So for that, however, there are things like TTN networks, the Things network. They are low-range networks, LoRa networks. So right now they are using this technology, but still it has to be sent to the digital object. So how to send this? This is a challenge. Number 2, time. The speed at which the data is generated, the speed at the rate at which the data is sent to the cloud is a challenge. For example, if at all I'm interested in our scenario, we were trying to get the CPU idle time. At what point in time the system goes to power save? At what point in time the system wakes up? Like you see in the mobile phone, it becomes black, right? So it's going to the power save. So at what point in time the screen becomes black? And at what point in time the actual Linux framework starts going to the power save mode. At what point in time the CPUs are shut off? Only one CPU will be running, all the other CPUs will be totally shut off, totally down. So at what point in time they started? So this can be in the order of milliseconds. So, but I have to send this millisecond data to the digital replica of mine. So how can I make sure that this millisecond of time I maintain it here? This is a challenge. Further, we are sending the data to the cloud. Now comes the security, confidentiality of data, privacy, data privacy. What happens if as we saw in this digital twin? So somebody's bed information I'm able to see, somebody's heart rate I'm able to see. Just by controlling the read-write permissions, is it sufficient? So all those things are a concern even now. And for example, if I'm an organization, if I'm interested in taking this digital twin, do I have the digital infrastructure? Because typically what is required for me, I just take, we are all, especially with our mentality here, so we are all cherry picking on what we need required. I require Windows. I'm just taking a Windows which is not even upgraded, not even patched, not even to the latest, right? So if I want a simple software, we go in for different versions of softwares which are not even latest, not even maintained, right? So is my company equipped to handle the digital twins? It needs the complete digital infrastructure. Having all these things put together, maintenance, who will maintain? Because it's typically people will maintain the physical object. But digital twin, once it's done, who will keep it updated? Who will maintain it? Where in the cloud somebody will invest? Who will maintain the cloud space? Who will maintain this IoT things? So maintenance is still a big concern. So these are different challenges in implementing digital twin. However, the cons are lesser than the pros. So the pros outweigh the cons. So wherever there are situations, we still can go ahead and implement the digital twin. Yeah, so this is what I had for today. So now the floor is open for the question and answers.
Yeah, thank you, Ahmed. I mean, it's a really very good session. So yeah, nowadays, I mean, so I also work for Hexagon Office. I mean, it's a cloud-based company. Right now, we also trying to implement digital twin for plant industry. I think you might have heard about. Yeah, you might have heard about basically oil plants. Okay, I mean, so the
Yes.
Aramco, one of the, I mean, basically
Yeah.
I can say one of the example. So there are multiple plants. I mean, there are many plants basically in the world. So basically, we also trying to implement right now digital twin. So we also align to this concept. So for you, in your examples, basically whatever you have given. So regarding car industry, the thin ID. So how they are going to connect basically? Okay, I mean I can understand that there will be sensors okay attached to these car parts, but how they will okay basically connect to cloud. So when they are I mean switch off. I mean, I came to know one of the case from my colleague. Okay, I mean, his brother-in-law has a car. Okay, and in night, basically, some animals actually cut down their wires. Okay, I mean, those are very sensitive wires. And in the midnight, he got a call okay from the corresponding company saying that okay there is some problem with your car, don't drive your car, otherwise okay you're going to have basically I mean some unpredicted things may happen if you drive the car. So that is a kind of okay in the midnight he did not took the call. So in the early morning again they called him, so assuming that he might be sleeping. Okay, in the early morning at 6 a.m. again they called and informed that so there is a problem with your car, don't drive this car. So I really surprised how they really connected. I mean, so when the car is switched off, okay, and how they basically raise this. I mean, the IoT, how IoT came into okay a picture here.
Correct. This is very good example. So, so the concept is very simple. See, what it requires for the IoT is just very simple: 3 volts or even at max to max 24 volts. So the battery is still on.
Mhm.
So it can send this data to
Okay.
the cloud. That's what
Okay.
it all depends on how the configurations are set up. Again, as I showed in this digital twin, right? The Eclipse, whatever I showed, there we have different ways. In one configuration, you can just say, I don't want it to be updated every now and then.
Mhm.
Okay. So you can configure that. In some cases, I want the data to be updated as and how, or as and when the physical object data is updated. In
Okay.
this case, so maybe the configuration was set up like that. Maybe they're not using Eclipse though. So they are using their own custom made digital twins. So at that point in time, whenever any sensor data changes, right, it'll get updated immediately.
Okay.
So does this answer the question?
Yeah, it partially, but what about connectivity? Basically, how it can make a connection to cloud environment?
That's what. So now the cloud, how do you connect to the cloud? As I
Yeah.
showed in the challenges, right? So there are
Yeah.
different ways of connecting. For a simple sensor, like maybe in this case, the car sensor, what we are talking of, right? So
Mhm.
there are things called as TTN, the
Mhm.
Things Network. You might be aware of, I don't know. The
Okay.
Things Network or LoRa networks, low range networks. So this
Oh,
will be enabled. That's what it all depends on how I have designed my digital twin.
okay.
So using this networks, right? So it will be able to connect to the closest cloud.
Okay.
And from there, anyways, so everything is internet connected, right? So you can get this information and then you can send this information to whatever customers you want.
Okay. Yeah. Understood. Yeah.
Yeah,
Thanks
great.
for clarification. Yeah.
Yeah, so good to know that you're also working on digital twin. So maybe we can connect offline whenever we are free, so that we can have some internship project for the people as well.
Yeah. Sure.
Yeah. Any more questions?
Oh, hey, there is something like a device twin as well, right? Where it connects to like IoT hub or IoT central.
It
So
could be
how?
same thing. People are just renaming it to
Um,
different things. That's all.
okay, digital twin and device twin, these are all same. Where it acts as a simulator, or if the device goes off, the sensor device or the IoT gateway goes down, still it can act as a device and then it can send the data when it comes online, when the network comes online. Is it?
It's
Right?
exactly the digital twin. However,
Okay.
what the difference that these people are making is, for example, many applications are dependent on this data, right? So
Hmm.
what these guys will do is they will put all the data on the cloud, also on the digital replica, whatever we talked of.
Mhm.
So this digital replica will have all the information that is required to process the application. So this they'll be able to get this data. So now at some point in time, the actual physical object is disconnected.
Right.
But still, you don't want your application to be down. You don't want your servers to be down. So you're dependent on the digital replica data. Whenever the actual physical data is up, then the IoT will get activated and then you update the information to the digital replica.
Yeah, it will start syncing again.
Exactly. Syncing of that. Like in our normal Gmails and all these things will happen, right? When we are
Yes.
lost with the network, so it doesn't sync. Same thing. So, but still for the servers or for the applications on the cloud or on the other places, right, to the customers, it still appears that nothing has happened, no downtime.
Yes. So it's Microsoft started this, I think, right?
Actually, no. That's what, so the concept has come from NASA though,
Uh-huh.
but different people have implemented it in different ways. Microsoft has its own, as I showed in the different tools, right? Microsoft has its own Azure platform for this one. And similarly, Amazon AWS has their own platform. IBM has their own digital exchange platform for this one. So what I
Even
showed, go
even
ahead.
IoT device also should have this capability, I think, like Microsoft Sphere some similar name is there.
That's what shows you IoT is a part of this ecosystem now.
Hmm.
So only IoT will not have all these facilities.
Right.
IoT
That's
is
what
a part of this one. Yeah.
So just the naming convention,
Yes,
but
exactly.
technology should be
Some people
different.
just tell it twins.
Yes, yes, but
Yeah.
thanks.
Yeah.
Assalamu alaikum.
Walaikum salam wa rahmatullahi wa
This is really great. I was just wanting to know from the perspective of a student who are right now, they are still going into college and who
Mhm.
like to study more about this concept, and what are the, like, if someone is wanting to invest in this area, is it going to last for a long time? Or, is it going to be beneficial for the students to learn this into this area, invest into this area? Or is it going to taken over by AI again? As we all, we think that most of the things are taken over by AI in the coming time. So
This is a part of AI, right? So AI is
yes,
a part, or I will take AI is a part of this one.
you're right.
So this way, this is going to stay long. In fact, that is why I made the statement.
Okay.
People are claiming that this is a stepping stone for the metaverse reality. So this one will pave way or will open up many avenues for the metaverse thing to come into existence. So because AI is also part of this one, so the fear that AI will take away this one is not there. Because we are anyways using AI.
This is great news. And where to go for learning more about this?
Yeah, so it depends of, for example, if at all you're a student and you just want to understand the concepts in detail, you want to maybe start off with a simple sensor or simple. See, we always get DIY kits, right? Do it yourself kits. So we can take any DIY kits. For example, if it all you're having some from, I don't know from what background you are in. So if at all you're from, say, engineering background and electronics background and these places, right? So we can take things like Raspberry Pi and simple sensors, or even Arduino for that matter. So simple things which will be less costly. You can take this one and you can integrate the TTN, the things network. It's all there in the net. So you can see the things network.
Okay, the
TTN,
Things Network is there.
the
Okay,
things
and
network.
there are no particular institutions where someone can learn about these stuff.
Because these are all
Not yet.
still nascent, right?
Okay, listen.
So that is why the Eclipse Ditto have come up with the open source platform, so that
Okay.
you can experiment things free of cost, do things whatever you want. Because the problem is, if at all you go with Microsoft Azure and all
Yes.
these things, right? So it's all subscription based. You need
Okay.
have to pay for it.
Fine.
So you
Thanks a lot.
experiment with Eclipse. Then if you're comfortable, then if you feel that, yes, this is great, I can do much more things, then you can plan for Microsoft Azure and IBM Digital, whatever it is.
Fine. I come from a teaching background. I teach
Okay,
in a
okay.
university. So
Great.
yeah, that's why a lot of students, I can like tell them, a lot of students
Sure.
learn about these things. Thanks a lot anyway.
Yeah,
Assalamu
welcome.
alaikum.
Walaikum assalam. Yeah, I think we are done with it. So thanks a lot for the participation. Thanks a lot for your time and patience in listening to this complete session. Thank you.
Thank you, brother.
Jazakumullah. And thanks to all the audience also for joining this session and also making it a lively session. So if anyone wants to connect with Zakir bhai for further collaboration in digital field, maybe Zakir bhai, is it okay for people to connect with you?
Sure. No
Do they want
issues.
to-
No issues.
Yeah. Maybe you can share your email ID or number, whatever you are comfortable with. So if any
So you,
student or people,
okay. So I'll share my screen here itself. Yeah, I'll share my phone number here itself. Use WhatsApp. Yeah, you can send messages in WhatsApp. So I might be late, but I'll respond. Inshallah.
Okay.
Yeah.
That's great, Zakir bhai. Jazakumullah. So with this, we close this session, inshallah. Nice having all of you around. Okay. Thanks to all of you. Assalamu alaikum wa
Walaikum
rahmatullah.
assalam.